Hello scholars, welcome. Mr. Hinkle here. Today we're going to talk about Earth surface processes that are creating a very vast, amazing, awesome feature of the landscape called deserts. So we will identify the characteristics of a desert, discuss the global distribution as controlled by atmospheric circulation, and then look at human impacts in the process of desertification, the aridification of various landscapes. So we are getting into it here. Deserts are defined by aridity, not temperature. This is really important. So there are both hot and cold deserts. There are polar deserts, there are cold deserts, there are hot deserts. But what deserts have is no permanent surface water. Ice is different than water. We're talking about liquid water for polar deserts. Deserts usually have less than 10 inches of annual rainfall. There's not much vegetation. And again, I mentioned hot and cold climates. What we usually think of is hot areas, camels, no trees whatsoever. But that is just the stereotype for deserts. They come in lots of different types, shapes, and sizes. So deserts are where evaporation exceeds annual rainfall. Again, this is aridity. It's how dry an area is. So less than 10 inches of rain, and then evap is greater than precip. There's extreme temperatures. They get really hot in the day and really cold at night. Cold deserts can get very, very cold because of the lack of moisture in the atmosphere, which creates low humidity, scarce cloud cover, high heat absorption, and emission. And it's all because of atmospheric circulation patterns, how air moves. So you might know this. Hot air rises and cold air sinks. If you're in a room that has bunk beds, it's hotter on the top bunk. Okay, great. Well, the hottest area is the equator. The coldest area is the poles. Poles are cold, equator's hot. You might know that too. What we haven't explained is because the Earth turns, there's this effect called the Coriolis effect. To the right in the northern hemisphere, to the left in the southern hemisphere. I have other videos that explain this in depth. But for now, hot air rises at the equator. As the Earth turns, what happens is that instead of that hot air rising and traveling all the way down to the pole, it breaks up into 3 convection cells. From 0 to 30 are the Hadleys, from 30 to 60 are the mid-latitude or the Ferals, and from 60 to 90 are the polar cells. Why is all this important? At 0 degrees, hot air rises. Hot, humid air rises, and it rains. At 30 degrees, cold, dry air descends, and it sucks up any available moisture. And so if we're to, look at this, I gotta stop stretching my arm so much. Look at how green it is at the equator. 30 degrees, there's the Sahara Desert. 30 degrees, southern hemisphere deserts. And then you have a desert at the pole and another desert at the pole. So all of this to say, the global distribution of the world's deserts are controlled by latitude because of how air moves, atmospheric circulation patterns. The poles have descending cold and dry air, both the North and the South Pole, creating with high pressure created by the polar cells. So it does snow at the poles, but it's cold and it's dry, so that snow does not melt. It persists, which is important because it helps us have the ice record that we use for understanding paleoclimate. Again, the global distribution, 30 degrees, 90 degrees, 30 degrees. Deserts occur where cold, dry air sinks. Not exclusively. The Earth is more complex, but we don't have deserts at the equator, and we don't really see deserts around 60 degrees because there is a large influence of how the atmosphere works on where deserts are located. I think that's pretty cool. So deserts are natural features of the landscape, but like everything on this earth, they can be impacted by human alteration, land use changes, by human effects to our earth. So this is a map of potential areas that are subject to desertification, the aridification of non-desert. It's basically taking areas that are not deserts and turning them into deserts. Happens basically, a big way this is happening is that deserts are growing, they're expanding, especially with human anthropogenic climate change. But it's not only that. Agriculture of crops and livestock, overuse of groundwater pumping, global climate change, all of these led to the Dust Bowl of the 1930s, where, what did we have? We had native grasses covering the Great Plains. And then farmers came in and they plowed the land, removing the native grasses, overgrazing, livestock, breaking up the soil, and then a drought hit, the drought of the 1930s, which led to huge dust storms causing massive amounts of soil erosion and soil degradation. So this is the textbook example of desertification, taking an area and then modifying the landscape, and then when drought came, it became a desert. Okay, so deserts, really awesome. They're dry, they're designated by how dry they are, not by the temperature. Dry being less than 10 inches of rain, evaporation is greater than precipitation. They're located globally where atmospheric circulation patterns are also dry, and the Earth is susceptible to human impacts for creating desert regions out of non-desert areas. So what we do on this Earth matters. What you do, the decisions that you make, the things that you buy, how and who you vote for, all matters because you are important and your choices have an effect on our Earth as a whole. Thank you so much, and I'll see you again.